All right, good evening, and welcome to Science Never Stops with the U.S. Space and Rocket Center. My name is David Weigel, and this is going to be a nice overview of well, I guess it's Alabama spring skies technically, but pretty well applies to anyone within about 10 degrees of our latitude. So that ends up being, somewhere between maybe 25 and 45 degrees north. And if you're watching from somewhere else, never fear, it's still some pretty things and still helps you jaunt around the night sky a little bit. Um, while we're waiting for some people to tune in and everyone to get this notification, I want to start by taking a look at the International Space Station. And I also want to pose the question to you, which is, what is your favorite thing to look at, to look for in the night sky? And sorry to get started a little bit slow this evening. I had everything set up, and then Facebook decided that it didn't want to do anything. And I clicked go live, and nothing happened, so that's always lots of fun. All right, so you should see a question pop up there, and go ahead and answer it, and I can hopefully help you find those things this evening. So the reason we're starting by looking at the International Space Station is because very conveniently, and I literally found this out thanks to Aaron, who's our planetarium visualization specialist. Found that out literally this evening at about 10 minutes ago from her. The ISS is going to pass over Huntsville tonight at about 9, not even about, at 9:24, beginning at 9:24, and will last for about 6 minutes. This is actually a really good pass. It'll get about 58 degrees above the horizon looking up, so that's a decent way up, and it will start sort of west-southwest and make its way across the sky for that 6 minutes and depart from view sort of in the northeast. So that's very exciting. So go check that out after the presentation tonight. If the clouds aren't too heavy, and actually I haven't been outside in the last little bit, so I don't know what the sky looks like, but definitely worth your while. And if you do miss it tonight, there is another opportunity, or two opportunities, tomorrow. So I'll have Aaron post that in the comments and give you some opportunities to spot the International Space Station. Basically, if you haven't seen it before, it's going to look like something very, very bright in the sky, brightest thing that you can see, basically, and will be zooming across the sky. It won't be blinking, so that's how a good way to distinguish it from an airplane. And it will be moving in a straight line and sort of go from horizon to horizon, and then dim from view. So tonight we are journeying through the visible sky from the southeast, or really, again, from latitudes maybe 25 to 45 north. And we're going to be using the software, free software called Worldwide Telescope. And you can follow along at worldwidetelescope.org if you so desire, or download it for yourself there if you have a Windows PC. And you can see this fantastic model of the International Space Station. We're not going to talk about that so much tonight, but it's beautiful and you can play around with it. And we'll post a link to Worldwide Telescope as well. Okay, so let's jump into, I'm going to pause our time now and set us up to about, I think 8:30 makes a lot of sense. So we'll pause us right about in there, and we're going to switch over to a view of our night sky. And right now we're viewing facing west, pretty well due west, and you'll notice there that we're looking at something very recognizable, and we see something sort of dark blue. This is our makeshift horizon because we're viewing from the Huntsville area. We're at latitude 34 or so. And this is Orion's belt right in here. So using Worldwide Telescope, you can zoom in with a scrolling wheel or a couple fingers sort of pushed up. And what's really neat about this is you can zoom until you run out of resolution. So we can see all sorts of pretty things like for example the Flame Nebula, which exists in the sort of near the belt of Orion, actually in the belt of Orion. Typically, we get, let's see, our context bar doesn't seem to be populating right now. My internet's unhappy. But typically in there you'll see different things that are visible from your area. But Orion is setting, and we really won't be able to see that anymore after the next few days or so, because it is indeed a winter constellation and we're nearing the end of summer. So you can bid farewell to Orion and bright stars such as Canis Major, the brightest star, or sorry, yes, Canis Major, the brightest, or Sirius, which is the brightest star in Canis Major and in the night sky that's not named the Sun. Talking is hard tonight. And you can start to find more spring and also into summer different things. So I'm going to bring up constellation lines for you along with their names and hide this to give you a bit of a bigger view, and we can take a look at what's in different parts of the sky. And again, this is at about 8:30 tonight. So hello to Colin, to Julie, to Carrie, to Lee, to Michael, Jessica, and Angelina and Natalie, and Andrea, and all sorts of people. Fantastic. Thank you so much for joining us. And let me know if you have any questions. So things that are very prominent in the sky that you can find, I think if we sort of look pretty well up, if I bring this back up, you can see that we're looking pretty high in the sky, a little bit south, but pretty high in the sky. And Leo is quite prominent in the night sky. It's something that is very recognizable because it has this sort of backwards question mark shape that makes the head and ends in the star Regulus, and then this sort of triangular backside. So if I was to toggle constellations for you, gives you a sense of how what you might see in the sky. And you won't see all of these stars in the Huntsville area, so it'll be a little bit more clear with all the light pollution that this is the sort of backwards question mark, and you can find the rest of Leo over here. So Leo is the mighty lion. So that's a nice prominent one to find. Also, if we look sort of due south, we have a very long constellation, one that is not particularly easy to spot, and that is of Hydra the water snake. You can see that right in here. And then we have Crater the Cup, which looks sort of like, I don't know, maybe a block with arms, sort of signaling for a touchdown or something. And Corvus the Crow. And there's an interesting story associated with these, which essentially is that Corvus was this beautiful bird that was the messenger and sort of helper for Apollo. And Apollo tasked him with finding some water. And so he took Crater the Cup to go get some water, and he got distracted by a fig tree. He ended up eating a lot of figs, and actually the result of that was sort of messy. If you've ever eaten too many figs, you know that can delay your journey back, and that happened to him. And so he was late in getting back to Apollo, and Apollo was rather furious, but Corvus wove this beautiful tale, this intricate tale of, you know, how he had to fight this spectacular water snake at the river's mouth, or at the lake that he went to. And it was his valiant efforts that even allowed him to get this crisp water in the first place for Apollo. And Apollo, as this Greek god, sees through it immediately and banishes him and turns him into this ugly crow that has this hideous sort of screeching voice, and curses his entire species as well, and also throws him in the sky as a reminder that he's not to be messed with. So yikes, don't mess with him, I guess. But either way, these aren't very easy to find. They are quite big. Corvus you might be able to make out. Crater's harder, and Hydra the water snake is just so big it's a little bit hard to find. But you can know that you're in the right place if you find the constellation Virgo, which is particularly evident with this star right in here, known as Spica. Spica is very bright, it's very blue, it's a very hot young star, and it's quite recognizable in the night sky. More on that in a moment. Question from Natalie, or from Angelina. How many constellations are there? And there's actually 88 that are officially recognized by the International Astronomical Union. The sort of 48 constellations that were popularized by the Greeks and then some were added to later on in history to give us 88 constellations for both the northern and southern hemispheres. So we in Huntsville, or even in the northern hemisphere, can only see a portion of those constellations, probably about in the 48 to 50 range. Whereas if you're in the southern hemisphere, you get sort of the opposite half. But no one, except for people on the equator, are going to be able to see the entirety of these. So 88 total constellations. Now, let's see if any of you answered my question. Oh, awesome, fantastic. And so we have some planets, we have some constellations, we have the moon, we have the International Space Station, Starlink, that isn't coming around for maybe a couple weeks. Those are the Spacex satellites. That's strange to behold. I think there's in the 60 plus now, and there's supposed to be 12,000, and then these little points that zoom across the sky. There's a lot of controversy with that as to whether they're ruining the night sky. Maybe yes, but it is what it is, and that'll be more arguments later, I suppose. If you like finding Venus, this is a great time. If you're looking pretty well sort of south and west, right before the evening, let's see if it's still up. There we go. There's actually 2 planets you can find in the early May evenings looking west. If you find the remnant of Orion as it's setting, and you find Auriga the Charioteer, and the very bright star Capella in here, then this little thing is actually going to be the brightest thing that you can see in the sky over here. It's dimmer in this view, but that right in there is actually Venus, this dot right in here. And then Mercury is really, really low on the horizon and will be rising a little bit as the month continues. So you can find Mercury low, which is not very easy to see, but definitely visible, and then Venus, which is the brightest thing that you can see in the sky that isn't named the sun or the moon, and is actually even brighter than Sirius over here. So very, very, very bright. So all fun things to see. So zooming back south, we talked about Spica in the constellation Virgo, and Virgo in here you can see Virgo is the Virgin, or the beautiful young maiden, and she's a little bit hard to make out in this view here. You can see very clearly that we have a head and arms and legs for days. Truly stunning. But if you need a little help imagining what she's supposed to look like, it's maybe something along these lines. Obviously, yes. But Virgo is recognizable with Spica, but if you aren't sure where Spica is, let me bring these constellation pictures down. We can actually look sort of towards the north, and if we can find Ursa Major, which is sort of upside down from this view here, Ursa Major is the Great Bear, and the backside and tail is known as the Big Dipper. So the Big Dipper and the Great Bear, Ursa Major, are not the same thing. The Great Bear is the constellation, and the Big Dipper is known as an asterism, which is sort of a simpler, easier to find picture in the night sky. And those are not really officially recognized, and you could make one up yourself if you so desired. So if you follow the handle of the Big Dipper, you can follow this curvature and arc to Arcturus, which is in the constellation Botus the Herdsman. Very, very bright star in the sky, one of the brightest. And then go that same angular distance in the sky, and you arc to Arcturus, and then continue on, spike down to Spica. That will help you find both of those. So Botus looks kind of like a kite, but he's the herdsman of the bears. Virgo, again, is the beautiful maiden. And I said bears because there are 2. Ursa Major can help you find the little one. So if we find these two stars on the end of the dipping part, these actually point directly towards Ursa Minor and Polaris. So they point to Polaris in here, and this gives you Ursa Minor, the little bear, and also the Little Dipper. And this right in here is the North Star. So that helps you find north as well. Now, if you're thinking, okay, well, Polaris is not the brightest star in the sky, how do I know if I've gone far enough? Well, you can, outside, you can hold your arm or your fist at arm's length. This is sort of hard to show on a webcam, but there we go. I'm confused here. Hold your fist, either one, at arm's length, and then extend your thumb and extend your pinky like this. Put one of them on Doobie, which is this star in here, and one towards Polaris, and they should more or less span that distance, at least as an adult. As a child, it might be a little bit small, but you'll at least be within the ballpark, and that's rather helpful. So another question from Julie is, do the seasonal skies just change the location you find the stars, or are there times some can't be seen? That's a great question, and sometimes you can't see some stars. So, like I said, Orion is setting now, and will be set until maybe late October or so, when you'll start to be able to see it in the very, very wee hours of the morning. So as we go throughout the entire year, you get the entire set of stars that you can see from your latitude. And typically, stars that aren't very near the north are going to be around for about half of the year or so. Okay, so there are various different things that we can find in the sky, and hopefully you take away that if you find Ursa Major, which is very recognizable, and find that Big Dipper, then we can find the North Star, point to Polaris, zing, like that. We can arc to Arcturus using the handle and find Bode as the herdsman. And then we can continue that curvature, spike down to Spica. And in the very early evening, we can find Venus sort of in the western sky, and Mercury rising earlier, or sort of higher, as the month goes on, and bid farewell to Orion. Now, going back to Virgo, something rather exciting has happened right now. Supernovae are very rare. That's when a star blows up, and you can actually see one in the constellation Virgo, or near the constellation Virgo, and that is in another galaxy called M61 Messier 61. So I'm going to zoom us to this right now, and as we zoom this way, you'll notice our higher resolution sort of background imagery tiling in, which is quite cool. This is a visible look at the sky. We could take a look at it in different wavelengths, such as infrared. That's not very good resolution, so it doesn't look so great. Other infrared wavelengths, this was a bad example. They're probably not high enough resolution. The point is, you can look in different wavelengths, and that's cool. So you can try that on your own. But this galaxy in here, you can see these bright 3 foreground stars, and if we take a look, this is a picture taken a while ago. If we take a look at a picture that was recently imaged, I believe this was in the last maybe week or so. This was actually taken by one of my good friends who is also a planetarium director down at Seminole State College in Sanford, Florida, sort of outside of Orlando, Derek Demeter. He likes to take pictures of the night sky amongst all sorts of other cool things. You should be his friend, and you should check out his picture. So if you notice, when we sort of fade this in and out, there's a little dot that is coming into view. You see that right in there? And this is a supernova. So this is a star some 55 million light years away in another galaxy that is comparable in size to our own, that exploded, again, some 50 million years ago, but we're just seeing its light now, and because of this distance involved. And this is a type 2 supernova, basically one that is due to core collapse. So that means that a very, very, very massive star, much bigger than the sun, burns through its fuel very, very rapidly. It burns hydrogen into helium and then heavier and heavier and heavier things. Once it hits iron, it trying to fuse iron into heavier things takes more energy than it releases, and so this doesn't allow it to maintain hydrostatic equilibrium, which if you watched some of our other presentations, is basically the balance between radiation pressure pushing out and gravity pulling in. And so if you don't have enough radiation pressure pushing out, gravity sucks everything in very tightly, and the core literally collapses on itself, and that results in tremendous explosion, and it spews its guts all over space and is extremely bright, and we're looking at one 50-something million light years away. How cool is that? So this is a picture taken by an amateur astronomer, although obviously he's quite skilled to get this, and you can look up other people's pictures of this as well, and it's pretty wild. I think it's worthwhile, I'm going to bring that down, I think it's worthwhile to show you some other views. This one is from the Hubble Space Telescope. It's not as broad, but it gives you some pretty exquisite detail. You can see that it is mosaic together, so we just don't have data in these regions in here. And then I can actually overlay an even sort of tighter net view of the core, also taken by Hubble. So M61 is this nice spiral galaxy, and what's cool about it is that, again, it's about the size of our own galaxy, but it's also one that is starbursting. So what this means is it's, as far as galaxies go, it produces stars a lot more quickly than other galaxies. It's burning through its fuel very, very rapidly, which is fun. And the result of this is lots of new stars, but it also means that some of these stars are very, very rapidly dying as well. So we've actually observed, I believe, 7 different supernovae in this galaxy alone. It's the second most observed, it's the galaxy with the second most observed supernovae in it, which is pretty cool. So this is a very, very active galaxy, and a very pretty one as well. Okay, cool. There's a question about if my friend posts on Twitter, can we put up that Twitter? I think yes. I don't know if he does, but he might. We can point you in his direction. Oh man, and we have a comment from Logan Curtis, who also works here, which is fantastic. And he wants to know if we can show where Comet Swan is. And I'm so glad you asked, because I literally spent all day doing this, and it was extremely frustrating, and it finally worked. So I'm happy to show you. So lots of cool things for you to see in the night sky that are not typical. Now we're going to take a look at a comet. So comets can be really frustrating because we find one and it's not very visible and it shows a lot of promise, and then they fizzle out through different means. They're pretty fragile as they get closer to the sun and heat up. And so we haven't had a really good comet in a while. And so there is a little bit of hype for this one, as there was for the one about a month ago that fizzled out and didn't live up to the hype. I am going to, let's see, I'm going to remove our sort of Earth here, so that we can see sort of the southern sky, we can see the entirety of the sky. And let's see. Okay, so I have a view from the Huntsville area as to what the comet looks like from, or what it will look like in the sky. So let me just set this up very quickly for you and make it never disappear. Okay, so if we set up this scrub, there we go. So I have this this set up from about, let's see, this is January 1st of 2019 all the way through January 1st of 2021. And so this is a look at how the comet will be visible from, as seen from the Huntsville area, over the next, over about a 2-year period. Keeping in mind that most of what we're looking at is in the southern hemisphere, so don't get your hopes up for viewing this very nicely from very northerly latitudes. Okay, so beginning here around, this is March of this year, you can see basically what we have in here. Let me try one more time. Right now all of our dots are decaying, and I don't want them to decay. So let's try that. Okay, cool. So let's start over. So from our view, this comet sort of takes this path through the night sky. It's not this strange path through the solar system, but based on the rotation and movement of the Earth, that's sort of what we see. And as we get into May, this is May 2nd in here, this is where it was situated. And actually on May 2nd, I'm going to stop right in here, because on May 2nd, we were able to get a pretty remarkable picture. This is something that was on Astronomy Picture of the Day, also known as APOD. And I can bring this up for you, and it'll give you a sense of how big this comet is in the sky. This is a tremendous distance. So this picture was taken on that day, and you can see the nucleus of the comet very, very bright. You can see this very exquisite structure of the tail in here. Very, very, very cool. This is from, let's see, Damien Peach, I believe was his name. And you can find this on the APOD website, which we can link to. And this is basically pointing away from the direction of the sun, and it made its closest approach to the Earth, I believe, a few days ago on May 12th. And as it reaches its closest point in its orbit from the sun, known as perihelion, which is, I think, May 27th, that's the intended date, or the expected date for its brightest. So right now you actually can see it with binoculars. It's really, really, really low on the horizon from the Huntsville area, which I'll show you here in a second. But it won't look like this to you. This is something that's a very long exposure and fantastic image processing. So you'll see sort of a fuzzy nucleus, and that's kind of about it. You won't see the tail very well. But it could brighten to maybe 3.5 magnitude, which is not extremely bright, but certainly visible in the night sky. And right now it's maybe at about 5 magnitude, which is dimmer. But hard to say if it will make a spectacular show or not. Typically, comets that are dustier make for a better show, and this one is gassier than it is dusty. So it is what it is. But to finish this visual for you, if we sort of complete the view, there we go. We can see that it'll make this sort of looping experience in here, and will be interesting over the next 2 years or so. So let me change the parameters back one more time, and let's turn on this decay. Let's throw it at about, put in about 16 data points. Okay, and I'm going to also I'm going to set time to today and bring up our location as well. And I need to sort of bring us to the wee hours of the morning. So we're going to advance early. Okay, so now you can see where this is situated. This is at about 4:30 in the morning. Let's get to about as high as we can get before daytime. Let's say about 5 o'clock. We'll leave it there. So you'll notice as we sort of change in time a little bit, you'll see that it does rise as the day continues, but its trajectory is taking it lower in the sky through these different constellations. So probably the highest it will get for us in the sky above the horizon is maybe, I don't know, the 16th, 17th, 18th or so. And then it will start to dip back down again. So on the 27th at peak, it will not be very high in the sky. This is only, let's see, we're only about 9 degrees above the horizon here, so that's really, really not good. Very, very low, and this is in the sort of northeastern sky here. So your prospects are not great in the northern hemisphere. Go to the southern hemisphere, except you shouldn't travel right now, so maybe this isn't the comet for you. I don't know. Unless you live there already, then congratulations, and that's exciting. Okay, so I've ignored your questions, and I apologize. Let's see. Do supernovas happen in a chain reaction from Colin? Typically, no, they don't. I don't entirely know why M61 is more common for supernovae, That's not so much my field of study, but we might be able to look that up. It may have something to do with the star bursting, like I was saying, but that's sort of my best guess. And then, let's see, Angelina is interested in what type of telescopes we might recommend. That's a long answer that I won't get into at the moment, but we'll get back with you on that. And then, what speed is the comet traveling from Brandon, who's my neighbor? Exciting. That is a great question. Quickly, we could figure that out, but I don't know off the top of my head. It's certainly zooming, so it's coming from sort of the furthest outskirts of our solar system, known as the Oort cloud, which is this sort of cloud of comets, maybe trillion to more comets, hundreds of billions to trillions of comets. These sort of elementary building blocks of the solar system, very, very cold, very, very far away. And every once in a while, one gets kicked on a nice trajectory towards the sun and gives us a show. And sometimes it doesn't, possibly like this one. Cool. All right. So, with that said, I think I'm moving my screen around. That's the wrong screen. Sorry about that. With that said, I think it's probably about time for me to wrap up. I think I've covered the things that I wanted to. So to recap, go check out the International Space Station tonight at 9:24 if you're in the Huntsville area, and also tomorrow night. We'll post a picture of that, of those dates and times and where to look. Check out the different constellations that we point out tonight, particularly Ursa Major and Minor, Arc to Arcturus, Spike to Spica, and you can find Boötis and Virgo that way, and then look sort of pretty well high in the southern sky to find Leo, and bid farewell to Orion in the west, and you can find Venus and Mercury nearby. I guess I should also point out you can find Jupiter, Mars, and Saturn early in the morning if you are looking sort of easterly, and I don't ever wake up that early unless I have to, but more power to you. So with that said, thank you for joining us this evening. Hope that you enjoyed it. Please remember that science never stops, not at the U.S. Space and Rocket Center nor anywhere else. And my name is David Weigel, and I hope you have a fantastic evening. Thanks so much, and take care.